All right, let's do a two-dimensional force problem. In this problem, we have three coyotes that are fighting over the carcass of a 70-kilogram deer. You are asked to calculate the acceleration of the deer. Take a look at this schematic here, and please notice one of these forces is at an angle. Let's take a closer look at that particular force. Now, the resultant vector for this force is 600 newtons. We are going to need to use trigonometry to resolve it into its east and its north components. So let's go ahead and do that now. Let's use the sine function first to solve for the northward component of the force. Again, 600 newtons being the hypotenuse or resultant vector. Rearranging this, we can solve for the northward component to be 424 newtons to the north. And you know enough about trigonometry to know when the angle is at a 45 degrees, that we're also going to get the exact same answer for the eastward component of 424 newtons. Now let's look at the remaining two forces. And let's draw our free body diagram resolved into components. Now remember, when you're working out problems, you need to be very aware of whether it's asking you to draw a free body diagram that is not resolved into its components or one that is resolved into its components. This one is resolved. So we have our eastward component that we resolved using trigonometry. We have our westward component from the schematic above. We have our southward component, and again, we have the remainder of our resolved 600 Newton component, which is 424 newtons to the north. Now that we have all forces resolved into north, south, east, west components, let's define our coordinate system. I would like to call to the east positive, to the west negative, to the north positive, to the south negative. Summing the forces in the east and west direction gives us a net force of 174 newtons to the east. Let's do the same for the east-west. For this summation, we get 76 newtons to the south. Now we have to put these together. In order to do that, what we're going to do is we're going to use tip-to-tail vector addition and solve this orthogonally using the Pythagorean theorem to find the resultant vector, which is the hypotenuse. So let's look at our Cartesian plane, and let's first draw our eastward force of 174 newtons. Now let's draw our southward force of 76 newtons, and from the beginning or origin, we can extend that, and we have our hypotenuse, which is the resultant vector, which is part of what we're trying to solve for. So, using the Pythagorean theorem, we can go ahead and solve for side C, which is the hypotenuse, which is our resultant vector in this case. And we get that it is 190 newtons. However, class, you know that acceleration is a vector quantity, and vectors have both magnitude and direction. We have solved for the direction or the magnitude, but not the direction. Let's use an inverse trigonometric function to solve for the angle theta. I am solving for this particular angle in this instance using the inverse tangent function, and I get 24 degrees, and we're not done yet. Let's use our cardinal directions here. South of east for the angle theta indicated on your screen. If you were using the other complementary angle here, you would describe this as being east of south. But at this theta 24, we get south of east. And so now we can use Newton's second law, and we can sum the forces and solve for the acceleration. Well, we have our force, and we have our mass of the object being accelerated, i.e. the deer, which makes this now a very simple problem. So we can take our 190 newtons and we can divide it by the mass of the deer, and we get 2.7 meters per second at 24 degrees south of east as our final answer. So in this video, you're doing essentially what you did in Unit 1 and Unit Not. You're resolving a vector into its components and solving orthogonally for one side and then finding the direction of that particular vector. And I'll see you guys in class.